Okay, so you all should have a copy of the code. I believe everybody got a copy. It does go on to the back, so there's a little bit more on it. All right, a couple lines, but I just want to go through the button press stuff right now. Okay? Now, I'm saying this, what I'm saying or not, you may not agree with. But I'm going to go and talk about this, and my guess is it'll take some time till around 4:30. It might be 4:15. All right? But after we get done with that, what I'm going to do is quickly walk you through a couple things in chapter 3, but ideally by 4:30 or so, we'll be finished for the day. And the reason for that is there is something to be said for creating your first app. I don't care if it's one that somebody gave you, but for putting it in, wiring it up, putting in the code, and getting it to work. I think at least there's some sense of satisfaction to doing that. Now, one thing that I'm just talking away from iOS for a second. One thing I got out of the last 2 days in the Android class, first of all, not all of you were paying attention when that tape was on. That's okay, honestly. It's not real easy. This is the second time I've watched it. And you don't have to look at me, Mark, and say, well, I believe you.
You're talking about the Android?
Yes.
It's iOS.
Yes. I know it is, but there's a point I'm trying to make here. So the point is, I think in the Android book, I think he made kind of a quantum leap from that tip calculator to what we went to in this program. I think so. You may not agree, but that's what I think. So what I'm saying is, I want to make sure we don't do that in here. So if we get this in, and you understand the code that's in here, now, if you want to, you can start tweaking it. What do I mean by tweaking it? All right, as an example, I put everything in button pressed. There's nothing at all to stop you from writing your own routines and having button pressed call other functions. See what I'm saying? You can write your own functions. So you could set it up, for example, you could take, you break up your check, maybe put the for loop in one function, maybe put where you're writing the stuff out at the bottom in another function, etc. Start to expand what you've been working on, your horizons, whatever the heck you want to call it. But looking at this, so we already went through this stuff up here, so I'm not going to go through this again. All right. You may or may not be aware of this, but and this works like this in a lot of different programming languages. When you call the square root function, the square root function in here expects that what you pass to it is a double. All right, I could pass the number 9 to it, but literally it expects that it's 9.0. That makes sense to people? All right. So when that stuff was set up at the beginning, basically, I'm coming in here and I'm doing a couple things. Okay, first I'm saying temp wrap, this equals unwrapped divided by 2. This is an older copy of the one, of the file. So what this is going to do, and we talked about this the other day, if my number is 97, okay, so 97 right now is number int. All right, that's what we did right here. We put a 97 in that box, okay, it's not nil. So now it's also unwrapped is equal to that. So that's the way that we're going to work with it for the rest of the program here. So it's unwrapped. All right. Is that number 1? No. So we skip this. Then temp equals unwrapped divided by 2. Okay? So 97 divided by 2. That should be a computer guy. And divided by 2, technically, the answer to that is 48.5. Okay, I don't think I'm doing any math that anybody doesn't understand. Now, I'm saying half equals double of that divided by 2. Why? Because when I first did that, remember, since it's basically doing an int divided by an int, it throws that away. Okay, I don't want that thrown away. So now half is going to hold 48.5. So does everything I said so far make sense to everybody? So now I'm coming in here. Is that number equal to 2? No. Is it equal to 1? No. So I don't have to worry about that. So I'm down into my if. So I'm going to go down a little further on the screen here. So all this stuff that's in here between this line, line 35, and this line down here, which is around line 60, that all assumes that what we're doing in here, we've put in a valid number. That's all it assumes, is we put in a valid number. Right there. Okay. So, you see what everything is set up to. So, for var equal 2, var less than the ceiling of that, what's the ceiling of 48.5? Somebody else. 49. Ceiling means give me the next highest number. All right? So now, the ceiling in here, I'm going to say start at 2 and go up to 49 and add 1 to it each time. This is a great example of a really kind of a crappily written program. And what I'm saying is, and this is what we talked about the other day, this is an old version. I didn't even realize I made the copy of the old version. I did. It's fine. How can we fix this program? Let's talk about a few ways. First of all this stuff that we're doing in here with a half and all that other stuff, you don't need any of that stuff. What you really want to do is if you get into here, Mike said it before, if we get into here, first of all, I never even tried running this program with a negative number in it. So I should be using the absolute value function. Does that make sense? So if a number I put in is negative, I should turn it to positive. Boom. So way up here, where I'm checking that. And there's an absolute value function in here. That's what I should have done. I didn't do it. That's what you should do. All right? Then when we come in here, again, this is where we know it's a number. Rather than going from 2 to half the number and adding 1 every time, we should be going by 3 to the square root of the number and adding 2 every time. I went through this the other day, but the way that this program is currently written, this is going to go and check 2, then 3, then 4, then 5, then 6, then 7, all the way up to 49. Does that make sense to everyone? No, I'm asking, does that make sense to everyone? Yes.
Although I see a problem. If you start with 3 and go to the square root of the number, what if the number's like 5 and the square root is less than 3?
You're right. There's more stuff that has to be checked. You're right. Right? But what I'm saying is, at least in this case, if we had changed that, all right, we could have set it up so we would have checked, what's the square root of 49? Well, that's an easy one, right? 7. So now, if I check 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way to 49, okay, or all the way to, I guess, half of 49, so to 24, that's going to make somewhere around 30 checks, between 20 and 30 checks. But if I write it so that instead of starting here, I start at 3, go to the square root of the number, and add 2 every time, now I'm going to check 3, then 5, then 7. That's 3 checks as opposed to 25 checks. Does all that make sense? What I will give you, promise, I'll check, I might even have it out there right now, but what I will give you is my improved version of this. I read off the wrong one, and I didn't realize, but it's good. Let's just make something out of it. So what this is saying is, every time you're going through this, all right, again, if you can divide the number by 2, this is going to, the way that I wrote it right now, that's going to handle all even numbers. Does that make sense to everybody? This if statement right here in lines 37, 38, or whatever it is, 39, 40, and 41, that's going to handle all even numbers. Because that number will be evenly divisible by 2. So we'll set is prime to false, and boom, we're done. All right? Otherwise, we have to check, and we have to divide unwrapped number, which is 49, we have to divide that by the number we're currently checking. And if that goes into it evenly, so for instance, let's say the number we were checking was 49. 3, no. 5, no. 7, yes. All right? But if we get down to here, in English, we don't know yet whether it's prime or not. So we're done, so we're telling it to add, go back up to the top of the 4, add 1, and check the next number. All right? Does that make sense to people? We've written prime number programs before. That's why I thought this would be a good one to start out with. and as Mike said, there still could be some bugs or whatever, something in here, where I'm sure it could be improved, even upon what I just told you. So we get down to the bottom.
Up to 6.
What?
You could hard code it up to 6.
I mean, there's a lot of ways we could do it. And I don't know if any of you did this, but, and I probably have told you about this before, but I'm always gonna remember this, because this is different than probably what I told you about before. I had people do a program once, where they had to figure out all prime numbers between 1 and 1,000. Okay? And you could use this, you could use either of those algorithms. And I'm not making this up. I had a student literally went and figured out, I don't know if he put it in the internet or what, figured out every prime number between 1 and 1,000, then did a switch statement. And listed every number that was prime out there. And afterwards said, is prime equal true? Or and then default, is prime equal false? I couldn't believe the amount of work somebody did to do that.
It would be fast,
Yeah,
but it wouldn't work beyond 1,000.
you're right.
So it's not flexible.
And it also, with the stuff we were talking about in the class, it basically implemented almost none of it.
Requirements.
Until
You
Jeff
met the
fixed them.
requirements. 1 to 1,000.
If we hit that else, I'm going to hit this in a second, but if we hit that else, that means that usually, probably 99.99999% of the time, we didn't enter anything. So we just changed the label here to say, please enter a number. All right? But if we get down, and if our prime flag is still set to true, and I want you to get used to this syntax. Remember, this is the way that you print a variable. This is interpolation. Inside of parentheses, you put a backslash, all right, and then the name of the variable. So this is going to say, for example, if I run it and put in 97, 97 is prime. If I put in 98, 98 is not prime. Does all that make sense? Yes.
Is there a way to put a string before the variable?
Yeah. You can put whatever you want in here. So I could have put the number right there, space, and then put this stuff after it. That's fine. You can mix them any way you want. You can put multiple ones of those in there too. All right. But this, for lack of better words, is replacing printf. All right. The stuff that's in here, the view did load and the did receive memory warning, I'll take your question in a second. We don't need this. Now, some books will tell you. In fact, a lot of them, and some of the Dytel stuff. All right, you may or may not have even noticed that when he was starting at the beginning. Oh, we're not going to use this, so I'm just going to highlight it and hit delete. I'm always really leery of doing that. All right, I just am. This right here, for lack of better words, and what I'm about to tell you is halfway between a truth and a lie. You did load, kind of like your constructor. Does that make sense? View did load. It's like a constructor, so that's where you're supposed to do any initialization that you have. Did receive memory warning. Remember that if you are setting up something for a phablet, meaning a phone or a tablet, you're talking about devices, all right, you're talking about devices that typically they're running on a battery, and I don't know about you, but if I wouldn't remember to plug in some of the stuff for my family, they wouldn't plug it in. All right? So they might have a ton of stuff loaded on there, and they might not have a lot of battery power. So that literally later is when we'll talk about stuff in here. That stuff. You had a question.
Is a small thing of syntax. Line 14, you're using number as opposed to unwrapped number.
And I probably should have used unwrapped number.
Yeah, that's what I think. So.
Yeah, you're probably right. All right. So I will look and see if I've got the other copy of the better one I wrote with the prime number. If I do, I'll print that one out and give you that one. All right, but you should all now be sophisticated enough users that you should be able to go in and make some changes. And if you say, well, I wouldn't have written it like, then write it the way you would write it. That's good. I like that when people say, well, you gave us an assignment, you gave us some hints, but I didn't want to do it that way. Good. Did you meet the requirements? Yes. Then even better. All right. Before we finish up, though, come on. Stop. We've gone through chapter 1, which was not exactly a blow-off chapter, but there also wasn't a whole heck of a lot of stuff in it. I think everybody would agree to that. All right? We went over chapter 2, which was that Hello World example, but we went over a little bit more of an extensive example than the one that was actually in chapter 2. I want to take just a couple minutes and go over the majority of the material that's in chapter 3. And we literally can do it fairly quickly. All right? All right. So chapter 3 looks like starts on page 51. It says, in this chapter, we write a more complex app. Well, if you've seen it, if you went and looked and read it or looked online, again, we talked a little bit about this too the other day. This is the app. All right? Again, it looks stupid, but the idea behind it is not stupid. What they're trying to show you is a couple things. All right? They say when you create this, you may have noticed, have you ever noticed when you start dragging your stuff out there, it does give you some guidelines as far as where to put stuff? The author says, go down maybe a third of the way, but move this over pretty close flush to the left, and call the button, put the text there left, then do another one right, then up above it, all right, put a label in there. I mean, that's pretty simple stuff, okay? That's the app, and the idea is you are going to set both of these buttons, both of those buttons, so if you click either one, that'll either say left button pressed or right button pressed. So you use the same event handler for both buttons. That's where that sender thing comes into play that we talked about, all right? So they go into some talk here. If you've never read this stuff, it probably is worth your time. They talk about Model View Controller here, MVC. And I've talked about it in other classes before. The view is literally, it's your view. It's your GUI. All right? The model, as it says, it's the classes that hold up the application. You got to kind of look at it this way. You've got a model, you got a view, and a controller. You got a model that's off doing its own thing. You got a view that's off doing its own thing, and you've got a controller trying to keep them both in line. All right? That's kind of what's happening there. That's what the controller's job is, because typically the model and the view don't communicate directly with one another. They communicate through the controller. And that's what they talk about on here. Okay? That's all I'll say. And you can read it, there's a little bit on it. All right, they have you make it here on page whatever it is, 55 or whatever. They tell you to make this, and they tell you to make it a universal app, which again is fine. Okay? A couple people had asked, it shouldn't matter in here. Okay, it shouldn't matter in here for most of these that we work on, whether you make it a universal app, all right, or whether you make it an iPhone app or an iPad app. It really won't. What you should start thinking about, though, is if you're going to create your own app, well, how are people going to play this? I watch people play stuff on phones. I'm amazed they can. Then I realize really how bad my eyes are, because I could never do that. All right? Okay. Next, they talk a little bit about the view controller, and they do mention in here a little bit of stuff in here, just in case you hadn't seen it before, on page, must be 56. Nope. 55. They talk a little bit in here as you go through and you start to look. Here's the stuff you have. It says there's a navigator that shows everything. That's fine. And they talk a little bit about what I just mentioned to you. What goes on in the view did load and what goes on in the did receive memory warning. All right. I've looked at a lot of apps. When I say a lot, I'm talking scores, not hundreds. I very rarely, if ever, have seen anything written in the did receive memory warning. All right? I see, depending on how a person programs, a lot of times there might be a lot of stuff in view did load. Mentioned this to you the other day, and it's not my intention to read or anything else. This is a very complete description, I think, of what outlets and actions are on what, pages 56 and 57. 56 gives you a little overview right there. As you go down halfway on the page, it talks about outlets, and as you go down to the next page, it talks about actions. And if nothing else, if you're confused out of that, start to think about what the words mean. And action really does specify. Action is equated with event handling, all right, somehow. And I look at just an outlet as being more passive. Again, that's the way I look at it. You may or may not agree with that. You may have your own way of looking at it, which is fine. Now, I want to show you this. This is at the top of page, looks like page 57, which is where we are right now. Because the author shows you right here on the top of the page. All right. It started on the bottom of the previous page. Okay? In fact, this is important enough. This might be the most important part of this chapter. So this is the bottom of page 56 and going to the top, oops. So the bottom of 56 going to the top of 57. It says, you may be wondering about the declaration why it ends with an exclamation point. Swift requires all properties to be fully initialized before the completion of every initializer. So when it starts out, it needs everything to have a value. The point is, when you stick a label out there, if you don't basically set anything up, it doesn't have a value. All right, when you wire it up, it doesn't have a value. So it says, unless the property is declared to be optional. When a view controller is loaded from a storyboard, the values, as it says, of its outlet properties are set from information saved in the storyboard. But this happens after the view controller's initializer has run. As it says, as a result, unless you explicitly give them dummy values, which is not desirable, outlet properties have to be optional. In English, I've shown you many a program, most of you in here at least, where we've done something like this, where I'll say int age equals 21 in other languages where you need to do all that stuff. What they're saying is that's a dummy value. And what they're saying is if you do this, then you got to do that. Okay? In English, that's what they're saying. It says, this gives you two ways of doing it. It says you can choose between which of these you prefer, but I prefer the second one because it's easier to use because there's no need to explicitly unwrap it later. All right? And notice what it says. Optional, needs to be unwrapped, is implicitly unwrapped. All right? Bottom line is this. If you start working on a program and you're getting weird errors, you might have to go back. If you notice that you've got variables that have not been initialized, try putting an exclamation point at the end. All right, I'm not saying that's always going to fix every problem that you have, but it'll probably get you started. All right. Then on the bottom of this page, they talk about actions. And again, the only action we've looked at so far has been a button. I did mention to you, though, when we looked at this the other day, all right, that if I were to remove this button from the prime number program, I could code up, I could hard code so that every single time I put something in, I removed the wrong one. Yeah, that's the button. So every time I put something in here, so if I put a 2 in here, this literally, I could have it set up so it said 2 is prime. And if I put a 4 in there, it would change it to 4 is not prime. See what I'm saying? We could do that, but then we have to wire that up. And if you do that, then it becomes an action as opposed to an outlet. I've looked, I don't think it's, maybe I'm wrong, I don't know if it's possible when you go and you drag over a label, if you bring it up, if it shows action underneath there. I don't know if those can be action or not. I didn't think they could. yes.
So would it be considered bad practice to just put exclamation points at the end of all of our variables? Or
It depends on where in the program, all right? No, I don't think it would be a bad idea. Question was, would it be a bad idea? If you're in doubt, just put an exclamation point at the end, yeah. If for some reason it shouldn't be there, you'll probably get a compiler warning anyway, all right? All right, then they show you the user interface on the next couple pages. I'm not gonna run through that because we've already talked about that before, okay? On the bottom of page, I'm going to turn up all the way to page 60 and go to the bottom of the page here. Okay, it says this is another way. So if it's more comfortable, everybody's different. Remember before when we were up in that corner and I showed you the thing with the 2 rings on it and I said that'll bring up the assistant editor when you asked about that? You can also go in and do view, utilities, show object, you can get it a lot of different ways. You can bring it up. It wouldn't be there, it would be view something else. But I'm just saying, there's a lot of ways you can do the same thing. Because sometimes what'll happen is I'll explain how to do something, and people are raising their hand, did you also know you can do it this way? Did you know you can do it? And sometimes, yeah, I knew it, and other times, no, I didn't even know that. All right? Liz told me something the other day. I'd never even done that with a picture box before. I don't know if you were in the class when that happened, but we put the picture box in there, and I didn't realize if you just right-click on it, there's a thing in there for adding the image. All right? And I just never tried. Okay? Now, I've mentioned this to you before, but I want to say it again because what I'm trying to do here, for lack of better words, is be complete, or as complete as I can when we're talking about this stuff. I thought this was 63, that's what it says here. Oh, but somehow jumped to 58, okay. Okay, again, get used to this. Get used to playing with this and looking at what's in here. I will tell you, if you go in, Mike didn't ask this, he asked a different question. But if you go in here, for the majority of the stuff that we do in here, until we get into a little bit more complex stuff, if you make that strong, the program should work exactly the same. The system, there's not enough stuff that we're working with where it's really going to be any kind of an issue. All right, but the suggestion is that virtually everything that you put in there on your interface, you make weak because you tell the system to handle it. So you don't have to. Yes.
just quick question. Tried to run it, and it had NS unknown key exception.
All right. I'll take a look at it. I'm gonna be done in 5 minutes. All right. Okay. So they have you paint the interface for several different pages in here. All right. And I'm just gonna. This is where I'll pick it up next time because I'm gonna stop here. But if you get a chance before next class, starting on page 71, they're telling you if you build the program the way most people do, notice what happens here. You created that button first. They had you do that on purpose, okay? Then you created the other button, then you made the label. And what it'll do is it tries to place stuff where it thinks it belongs on the screen, which usually isn't where it belongs on the screen. So if you start reading on page 71 after this picture and you read the last 14 pages, they start to get into some of the stuff you asked about. They talk about auto layout. I don't profess to be an expert on it, all right? And also, so what I'm gonna do is I wanna show you what they did, and I'll do that in the next class or the class after that. So if you get a chance, please take a look at that, all right? So you've got the code in front of you. I'll see if I've got the other copy of the other code that used the square root. If I find that, I'll run off a copy of that and give everybody a copy of that also. All right? And again, for next class then, the first hour, I won't be here, but I'll have some instructions and some stuff for you to do. And please, somebody remind me, even if it's 2:30, all right, on Tuesday, to open that darn cabinet up. So when I go over there, you know, I don't want it where you don't have machines. All right, I know some of you have your own machines, but for the rest of you. All right, so that's all that I had.